Hello, welcome back to our HOPE conference. This session is called Advanced Wi-Fi Hacking with $5 Microcontrollers. We have with us Cody Kinsey and Stefan Kremser. Cody's with a security researcher with Varonis, and Stefan Kremser is a computer science student. You want to say hello, guys?
Hello.
All right.
Hey, nice to meet you.
Okay, very good. All right, so we're going to go right to your video, and then we'll have some questions right after the show. We'll see you there after the show. Thanks.
Hello, everyone. Welcome to our talk on Wi-Fi hacking with microcontrollers, although the alternative title to this is Why You Should Be Afraid of Smart Light Bulbs. Today, I'm also going to be joined with Stefan Kremser, who is the creator of most of the software that we're going to be talking about today. All right, so who am I? Well, if you haven't seen the Nullbyte channel, the Hack5 channel, the Ready channel, or the Security Forward channel, I am the host of all of those shows. I also have started the production company that's behind all those shows called Redia. So if you see Redia, that is me. If you want to follow me after this presentation, you can always do so on Twitter at Cody Kinsey. And my specialty is Wi-Fi hacking, open source intelligence, and generally just really small, cheap devices, because I'm really interested in the types of devices that anybody has access to and that are really, really cheap to buy. So that's what we're going to be focused on today. And there are a bunch of contributors to the ability to hack Wi-Fi on the ESP8266. The most substantial contributor is Stefan Kremser. Stefan, you want to introduce yourself?
Hello. Yeah, I mean, I wrote the thing we're gonna talk about most of this talk, I guess, the ESP8266 offer, and yeah, I do a bunch of like microcontroller hacking stuff, mostly Wi-Fi though.
And Stefan is based in Germany, I'm based in the United States, and our other friend James, aka Howdy Burgers, which is his hacking handle, is based both in the UK and in the United States. And James, you can see all of us here at the C3 Hacking Conference. We all met and started working on a couple ideas to really push the envelope in terms of what this could do. I had a lot of ideas for Wi-Fi attacks that I wanted to try out, as well as some Wi-Fi games, and Stefan had a ton of experience making these little devices do things that they weren't supposed to do. Now, combined with James, who managed to create a really simple interface for us to use, we managed to put this push this project a lot further than we ever really thought we would. So we're really proud of our results, and you can see here all of us having a great time at C3, and also everybody that isn't James is also James. So we also were inspired by some other people's work. Personally, I was really inspired by Matthew Van Hoff. He is a Wi-Fi security researcher who has discovered a number of really interesting attacks against Wi-Fi, both WPA2 and the upcoming WPA3. I had the opportunity of interviewing him fairly recently at a conference, and I was really inspired by some of his work that we'll be citing today in our presentation. So I'm going to let Stefan explain what a microcontroller is, because it's an important thing to understand when we're talking about what these things can and cannot do. If you've worked with like a Raspberry Pi before, then it doesn't really prepare you for what this is, because this is a level below a Raspberry Pi. It doesn't have an operating system. It requires you to know, if not a little bit of programming, then at least how to upload other people's programs. So Stefan, go ahead and take it away and explain what this thing is that you've been working with for several years now.
Yeah, so basically this is a very small, inexpensive piece of hardware that you can program. So yeah, think of it like some piece of hardware that does a thing. For example, it has Bluetooth or Wi-Fi, which is what we are going to talk about today. And yeah, you can program it and tell it what to do, like open an access point or whatever. And the code runs directly on this piece of hardware. So this is like a tiny computer all bundled into one chip. And yeah, you can program this, for example, with the Arduino IDE, which makes it a lot more user-friendly, and you can tap into the whole community there. But you can also, if we're talking about the ESP8266 in particular, use MicroPython, Lua, or other languages. But the Arduino IDE is probably the most common and user-friendly way to program this. So what's the difference to something like a Raspberry Pi? Essentially, a microcontroller is something you program, and the code that you flash onto it runs then bare metal directly on the hardware. There's no operating system in between. Maybe there is some like real-time operating system, but that's something more specific we won't cover here today. But essentially, you flash a piece of software, so a piece of code, compiled code onto the memory, and then this piece of hardware just runs it. That's it. You have direct hardware access to the inputs and outputs. So these like I/O pins you can see on the picture on the left, we have a LED connected that you can control, which doesn't have resistors on there. Cody, what did you do there?
I always do that. Resistors are meant to be destroyed in the pursuit of science.
Yeah, whatever. It's a 3-volt microcontroller. It's gonna be fine. But essentially, these things are low power, small size, and often very cheap. And you have this very direct hardware access. But a Raspberry Pi is more like a tiny Linux computer. So you have Linux running. You need like a micro SD card to install it. The advantage here is if you're used to Linux and like desktop OS kind of things, you can just run the same code on this thing because it's like a tiny computer. It runs the same software. It has a lot more computing power. Less than like a desktop computer, but a lot more than something like a microcontroller. But that also means that it's bigger, it's more expensive, it gets hotter. It's not really a thing for all applications you can think of. But compared to a microcontroller, it has advantages and disadvantages. One advantage definitely is that you can run the same code because it's Linux, but you also have desktop like I/O, like USB, Ethernet, and those sorts of things.
Yes, you need a lot of accessories to get started with it as well, as opposed to a microcontroller where you just plug it in.
Right, yeah, the microcontroller, you just flash it and then it runs something. The Raspberry Pi, you have to install a bunch of stuff to set it up first. So how would you program a microcontroller? I already mentioned the Arduino IDE. And basically how this works is a very oversimplified version. You get some piece of software, for example, the ESP8266 offer that you can get on GitHub. Source code is available there. So you download that piece of code or you write your own, open it in the Arduino IDE, which is like a very simplified, user-friendly IDE. You select the board you want to upload it to, so the kind of microcontroller or development board you're using, and then you just press upload. It will compile the code and send it over USB to that microcontroller, and then you have it flashed, have the software installed. That's kind of it. So what is this ESP8266? Essentially, this is a Wi-Fi system on a chip. So it's a tiny computer with a tiny computer with Wi-Fi, all in this tiny 5x5 millimeter package. You can see it in the top right corner there.
I'm sorry, what's a millimeter?
Or 0.2 inches.
Thank you. Sorry, this conference is in America. Sorry, guys.
Right. Okay. So tiny thing, all in one little piece of hardware. But again, then like, what do you do with this chip? Like, can't really access it. So that's where development boards come in. So some development board examples is the VMOS D1 Mini. Maybe you also have heard about the Node MCU. The VMOS boards are something you can see in the bottom picture there. And those are insanely cheap. You can see it starts at $1. And that's essentially a little PCB that has the ESP8266 on there, together with another chip and a USB connector. So you can talk to it over USB. Also has, the required power management and also breadboard friendly pins. So you can put it in a breadboard and control LEDs and that sort of things. Basically making the whole thing very accessible, easy to program, and makes it easy for you to get started right away. There are plenty more dev boards. I just named the most popular ones, and the price is insanely cheap. So where can this be found? Essentially anywhere, like in any IoT device. So you can see here the light bulbs. I actually made a video about this, and I think the bottom left corner picture is actually from the thumbnail of my video, where I bought a bunch of these cheap Wi-Fi enabled light bulbs and opened them. and I found all of them had ESP8266s in them. And in the bottom right picture, you can see me trying to flash actually one of them. I sorted on a bunch of wires to make it accessible. But yeah, essentially, it's the same chip as on like a development board. So if you find this, you can just reflash it with the same software, with the same Arduino IDE. And it's crazy. You can put, there's like an open source project for this as well. So yeah, kind of funny. So you find
So
this
think about evil light bulbs is kind of the subtext here. Not on this particular demo, but think in the future evil light bulbs.
Right. What we are going to talk about is like how you can hack with this Wi-Fi chip. It's quite interesting if you think about where you find this, and that's in like all kinds of IoT devices. And yeah, just think about you can reflash and like override the default firmware and have like a light bulb do all the crazy stuff we're gonna get into now as well. So maybe you have also heard of the ESP32. I'm just gonna go over this quickly. It's the successor of the 8266. It has more power, has a dual core, a lot more RAM, more I/O, but most importantly, Bluetooth support. So that can be quite useful. And yeah, a bunch of more pins you can see in the bottom. Not always breadboard friendly, but if you have applications that need that, then yeah, that's more useful. But it also means you pay a higher price. This is a chip more around $5. If you buy just a chip, then it's a bit cheaper than a development board. But yeah, in the grand scheme of things, still very cheap. And that's, yeah, you find this basically anywhere you would find an ESP8266, but in applications that require a bit more data processing. Because of the more RAM and CPU power this chip has, it can do stuff like basic video streaming or surveillance or even facial recognition. And that's where this ESP32 CAM dev board you can see on the right bottom comes in. You can actually buy this, quite easy to use. And Cody actually made a video on, I think, Hack 5, right? Where you use this.
Yeah, so if you want to check that out, we have a video on using the ESP32 camera's facial recognition built-in capabilities, and then how you can actually break them. So if you check out Hack 5, defeating facial recognition, there's a really good video on how these little microcontrollers can actually do facial recognition and how to mess them up.
Yeah, it's crazy. So again, differences real quick. The 8266 has more limited power, but and it doesn't allow us to sniff full Wi-Fi frames, but we can still access like the basic metadata, which is essential to the types of attack we're going to talk about. It doesn't have Bluetooth. It does, however, allow us to do unrestrained packet injection, meaning we can define our own Wi-Fi packets, our raw frame data, and just send that out over the radio. No restraints, basically. Meanwhile, on the ESP32, we have a lot more power because of the dual core and all that stuff. It offers a better sniffer API that is like unrestrained in any way. So we can sniff all types of packets, full length and all that. It comes with Bluetooth as well, but it doesn't allow us yet to inject our own packets completely unrestrained, at least. Only a few. So for example, it can't deoff, which is a attack we're gonna cover today. So basically, think of it like the 8266 right now can send whatever we want, and it's really, really cheap, but it doesn't have that much power. But the ESP32, a bit more expensive, can do more of the signal intelligence stuff, but it can't really send packets, not as well. So the 8266 for security research. Yeah, so with a guy I partnered up with, we actually created these development boards that you can use, that you can just buy and pick up and use as a hacking device. So this comes with a firmware I wrote pre-flashed. And because it has this little OLED and the little button and LED, it makes it very easy to use just right away. But it's still a development board, so you can actually flash your own code onto it. So that's really useful. And yeah, it removes the whole having to interface over Wi-Fi to controllers or any other things. It's just like you buy this thing, you pick it up, you can use it right away. So how did the ESP8266 learn to hack? Basically, it was always able to do packet injection and sniffing, but these functions are not really well documented. There are also some limitations. For example, you can't sniff the full packet length and you can't inject all types of packets. But if we use an old SDK and apply some changes, we can actually undo the whole sender restraints. So we can send whatever type of packet we want. And the combination of this sniffer and an unrestrained packet injection means that we get a tool or piece of hardware that we can use to turn into a very good hacking tool, because we can do most kinds of Wi-Fi attacks with this. We can't get into like stuff that runs in the network, like if you're connected to a network, for example, that's more complicated if we talk about encrypted connections and those sorts of things. But everything that works on the overlying Wi-Fi layer is doable, even though the sniffer is somehow limited because we can get all this metadata. We can do all these great attacks we're going to talk about now.
Cool. So I'll take over here. This is where actually I originally contacted Stefan over Twitter because I was doing research into all the different attacks you could do and all the cheapest ways of pulling them off. And the deauthentication attack has been around for a long time because it's a fundamental flaw in the way that the Wi-Fi most people use every day works. Now, what happens here is basically the short of it is that using this little tool, you can kick any device off Wi-Fi and it will not be able to reconnect until you decide to let it reconnect. And the way that works is this device is able to read all the packets that are flowing around it and determine the MAC address of the router as well as any devices that are connected to the router. Now, this tool can basically lie. It can allow the ESP8266 to send packets that are basically foraging who they're from and directing them to devices that we want to kick off. So if we want to kick a device off the network, we can send a packet called a deauthentication packet to the device and lie and say that it's actually from the router. And the device will just accept it as a fact because these packets are unencrypted. They're used to manage connections, and because they're often used before a device is fully connected to a network, they can't be encrypted and they need to be in plain text. So we can take advantage of that to basically use this small tool to lie and figure out what the MAC address of any access point nearby is so that we can kick their clients off and do so either continuously or just once in order to do something like grab a Wi-Fi handshake. Now, another kind of attack we can run is called a disassociation attack. And this is basically a very similar type of packet that's used for everyday things. And it's important to note that these packets are normal. They are used to regulate Wi-Fi connections. Maybe you're moving to a new Wi-Fi network, or maybe you're going out of range. Maybe your phone turned off the Wi-Fi connection. That's what these packets are for, and they're necessary to maintain normal Wi-Fi connections. So what we're doing here is we're abusing these normal everyday packets to create undesired behavior on the network by targeting a specific device and bombarding them with packets that seem to be from the router, telling it to disconnect. Now, these packets have slightly different effects on different devices because some of the way Wi-Fi works is determined by the manufacturer, and we can use one or the other of these packets in order to attack devices that are on the network according to the tool that Stefan has written here. So why would you want to do this? Well, as you already mentioned, you can use this to attack things like IoT devices, like maybe a web camera that relies on an internet connection in order to be useful. You can target individual devices like maybe a cell phone or a laptop. Or you can also just do this to herd a device from a safe network onto a sketchy one, which we're actually going to be doing a demonstration of today, where we get someone to automatically join an evil access point using the ESP8266. Now, if we have another Linux computer like a Raspberry Pi, or even if I just have this MacBook Pro here, I can pop open Wireshark and then use the ESP8266 to briefly disconnect any device from the network. And as soon as they reconnect, I can capture the Wi-Fi handshake and try attacking it with a tool like AirCrackNG, which could give me access to the Wi-Fi network in its entirety. So I like to think of these as almost a replacement for a wireless network adapter in some regards, because they're kind of like a programmable wireless network chip, where you can preload it with different behaviors and then script them to do basically whatever you want in order to maybe help out another attack, or be able to do something like generate a Wi-Fi handshake in order to save time, or if you're on a device that's not capable of doing this sort of packet injection. So our first application of this, and one thing I was fascinated by, and you'll see I think the link on the next slide or in the resources, is the deauth detector. So this is an application where we just use an ESP8266 and with no resistors, Stefan, no resistors, plug in a 3-color LED. And what this does is it allows us to, anytime we detect these packets at a certain rate, so let's say more than 3 per minute, we turn on an LED and say, hey, there are deauth packets flying around or directed at my network. Or, hey, there's disassociation packets flying around. Or, if we get both, then I think it's red for one and blue for the other, so we get purple. So if we see purple, then we know someone's using a tool that's sending a combination of deauthentication or disassociation packets. And actually, I was able to show that you could determine the exact type of tool that was being used to attack a network by looking at the pattern of deauthentication versus disassociation packets through just visualizing it with an LED. So something like MDK3, when you use it, just flickers back and forth between the two packets, but something like Aircrack or AeroPlay NG only sends one type of packet, so it only keeps hitting it with deauthentication packets over and over. So it's a really interesting way of detecting attacks as well as finding out what tool someone might be using. So we can also do Wi-Fi scanning and signals intelligence. And what we can learn here is what Wi-Fi access points are nearby, what their clients are, basically also clients that are not connected. So clients that are nearby but haven't associated with an access point yet. We can also see from those clients that haven't associated yet, I guess I would say, trusted networks or networks that they've connected to in the past. So this is a feature where a device that has recently connected to Wi-Fi networks is calling out for them in plain text using the real name of the network. So we can identify information about where a device has been by listening to these broadcasts. We can also determine the manufacturer of devices and even search through them by this. So if we want to find, for example, every Nest camera in an area, it would be relatively simple for us to do so. We can also determine signal strength information. So this gives us relative information about how close a device is, maybe if it's increasing or decreasing in signal strength, or when it's present or not present. And we can also see activity. When is somebody using data packets, or when is someone actually connected to a network using it, or when is their device just idly connected to the network, not actually being used. Now, another application Stefan made possible through his PCAP library is the ability to actually save in an Arduino device a PCAP file to an SD card. Or you can, well, in a limited fashion, stream it to Wireshark and be able to open packets and see them, but they are limited because you can only see basically what's called packet metadata, or the first part of the packet, because the rest of it is cut off. So the ESP8266 can't see everything. The ESP32 is more capable of digging into packets and better suited towards doing the sort of packet sniffing. But the fact that you can use this as a packet logger to do something like determine when someone comes and goes from a house or something like that is a really cool application of this sniffing ability. Now, I really like the ability to create fake networks. And the ability to create fake networks is something that leads into some of our more advanced attacks that we're going to go into in a little bit. Now, there's two different types of fake networks that we can create. We can create purely fake networks that basically devices could never actually join. And this is called a beacon spamming attack, where we're creating the appearance of all these networks by broadcasting the packets that advertise a network is there without any of the subsequent packets that allow a device to connect. Now, the alternative to this is that we can also create an actual access point that someone can join. And this means we can capture devices or basically have them join our network and then do something like either drop the connection so they're not able to connect to data or serve them up a phishing page. Now, in our first example, devices still will react as though these networks are real. So even though we're creating fake networks, devices around us will react as though they were real. And we can, for example, monitor when devices are trying to connect to these fake networks in order to determine which one of these fake networks they've connected to in the past. So now we're going to get into the first version of the Wi-Fi deauthor, the V2, which has a lot of really powerful features that make it easy for beginners to learn and use on pretty much any device. Stefan, you want to explain the Wi-Fi deauthor V2?
Yeah, you said first version and then V2. This is the second version.
Sorry.
So the current version. And it's like this Wi-Fi attack platform. So basically a piece of software you can flash onto an ESP8266, and it can run all these attacks that we're going to talk about or already talked about. And makes it really easy because this thing basically it runs on any ESP8266 development board or just like the raw chip. You just have to get the code onto it and then somehow give it power. And it will open an access point, so a little Wi-Fi network you can connect to, where it also hosts a little web server. So if you then go to the right IP address, you're greeted by a little web interface where you can control the whole thing. And this tool allows you to do beacon spamming and the DOF attack where you disconnect devices. And you can even script to a certain extent the whole functionality. So this is the web interface I talked about. We use the Wi-Fi interface. We also use to attack and sniff for devices. We can also use that to have this access point on and this web interface available for you so you can control it. This is basically a way of to control this tool. It's very easy and user-friendly. And when you start it, it automatically scans for devices nearby. So you can see it here, you can see the networks available, and you could just connect and run some attacks on them. So the deauthentication attack is the most basic, but also the most powerful attack, I guess, because when you run it, you will just continuously disconnect and therefore effectively block a specific Wi-Fi connection. So basically how this works is we select a target and then we just start the attack. This has some limitations, talking about the web interface here. Because we only have a single Wi-Fi radio, we can either run these attacks or serve the web interface, not both at the same time. It also means that when we are actually scanning for devices, the web interface and the whole access point has to shut down. So this is also unavailable. It will then go up online again, but if the scanning time is too long, you will be disconnected and might have to reconnect manually. You can't really do more advanced attacks. For example, something where you would try to phish another user by serving like a fake page, because we are already using the web interface to serve a page that controls the whole device. There is, however, another way of interfacing with it, and that's the USB serial connection. But as of right now, the version 2, there is no good cross-platform tool for it. You can use the Arduino serial monitor, which I used for most of the time, because Arduino IDE works on most operating systems. There's also PuTTY, Screen, and other serial monitors you can use. The whole point is the experience isn't really smooth across operating systems, and you will always have some sort of setup you have to go through first, and that's not really user-friendly. So while this is a way to control the device without having this whole, shutting down the Wi-Fi, the access point while you're running an attack, it isn't really user-friendly with the current version. But this brings us to version 3, and that's also where I focus most on the serial interface.
It's so pretty.
Yeah, so the whole idea is with this version right now to dedicate on more advanced attacks, more advanced signal intelligence, because through that serial interface, it's basically like a little terminal where you talk to the ESP8266 through that USB connection. And the whole goal is to interface more advanced kind of attacks and all that stuff. And as you can see, it's pretty formatted here. You have colors and everything. The whole idea is just to make it a bit more advanced and circumvent this whole Wi-Fi radio problem by using the serial connection. And that's possible through the Hunitor, a little Rust-based cross-platform serial monitor maintained by James, aka Howdy Burgers, and me. This runs on all operating systems and makes it just much more easy to connect to the ESP8266, because you just install this little tool, plug your ESP8266 in. It has to be flashed with the DOF, of course, but then it automatically connects and gives you this properly formatted, colored output, and it just makes the whole experience easier and fixes this whole problem we had with the old version, where you don't really have a good experience because you have all these different serial monitors and all that stuff. So this is our own little application specifically made for the V3, and just makes the whole serial terminal more better.
Cool. So this is where I'm going to cut in and show basically some of the attacks that are made possible with the Hunator and some of the advances that I think people will find very exciting. So if you want to start scripting attacks with the dauthor v3, it is extremely easy to do this. And basically what you can do is find a command that consistently gives you, in this case, a whole bunch of fake networks that look really convincing for the Southern California area. I can just script all that and even make compound commands that are really complicated and long and save them all in a text file. And I can execute these one by just using the hoon read command. And in this case, I've selected one that creates, I think, like 65 fake networks that are really common in the Southern California area, and then also monitors for devices that are attempting to connect to it. And we'll take a look at what that looks like in just a little bit. So if you're a total beginner, you can also just use the start command. And this will basically give you an interactive series of prompts that lets you do anything that the device can do and gives you all the optional settings in a series of just questions that where you can either press enter to do the default value, or you can put in what other custom settings you want. And it'll format a command for you at the end that's exactly what you wanted, which helps you kind of learn the command system if you don't want to go through the very long but very helpful help menu, which you can just type help at any time to see. Now let's take a look at something we can do that's very simple. This is a command that we'll use to just identify every Apple device around us. What I like about this is it's shareable and it's repeatable. So we can use this to share things with maybe another hacker who wants to do something that relies on first identifying Apple devices. So, play, not advance. Here you can see I'm using scan, and then I used two semicolons. And what that does is allow me to chain commands together. So first I did a scan, then I did semicolon, semicolon, wait, and I'm basically waiting for the first command to finish executing, so the scan will finish. And then I did a results command that filters for Apple devices as the vendor. So as soon as this scan completes, you can see the second command ended up finishing, and there we were able to locate the only Apple device in our immediate area. And this should work for you too. If you run the same command on your computer or on your ESP8266 dauthor, you should be able to also find any Apple device around you using basically the same script. So the repeatability is really what's cool about this. Now, I took an attack that was documented by Matthew Van Hoff and really wanted to apply it to this platform. And as I mentioned before, I was using the beacon spammer to create like 100+ fake networks that were really common in the Southern California area, and monitoring for which were the most popular, or which of those had the most devices nearby automatically attempting to join them because they had joined that network in the past. Now, what we were able to do here is use that to basically unmask these devices that are trying to connect. And what I mean by that is that every Wi-Fi device, like a smartphone, has a MAC address that is able to be tracked if it never changes. And because of that, manufacturers make sure that that MAC address is randomized when you're just out and about so that nobody can track you from place to place. Now, I can basically peel back that layer of protection by creating a bunch of fake networks. And if any of those fake networks match a network that you've joined in the past, your device will automatically assume that network is safe to join and attempt to join the network using its real MAC address, allowing me to track you and also removing the layer of privacy and protection that these manufacturers have built in. So we're going to use this tactic to create 60+ fake networks and then monitor which ones are basically getting the devices nearby excited and getting them to want to join because they've basically joined that network before. Let's see what that actually looks like. So I'm using the script that I wrote, which is the beacon script. And as you can see, it just automatically creates 65 fake networks. A lot of them are restaurant networks, there's some coffee shop networks, but these are things that are pretty expected. And here we can now see that we're monitoring attempts to associate with these networks. So we're seeing the MAC address of the individual devices that are now attempting to, they think they're at Burger King, so they're joining Whopper Wi-Fi and also joining the Marriott Wi-Fi. So this is a really, really cool way that we can not only identify which networks devices nearby will join if we want to hit them with a more advanced attack, but we can also unmask devices near us so we can verify this is the same device, even though it's trying to use MAC address randomization. Now, kind of the crown jewel of this is forcing a target to join an evil access point, as you see this hacker doing here manually. Now, we're going to do this automatically by combining our previous attacks to first identify the target we want, Then we're going to kick it off the access point it's currently on, and we're going to serve up an access point that we know it will join because we basically did the previous attack, and we were able to identify networks that are in what's called its preferred network list, or networks that it's joined in the past and will automatically connect to. So let's see that in play. Here, we're going to simultaneously, using our semicolons to separate the two commands, doff our target, and then also create an access point that's called testnet. And in this case, my computer is connected to an open network called testnet before, so it should automatically connect once it's been disconnected. So once these compound commands run, and these, because I didn't put wait in the middle, will run simultaneously, so they'll run in parallel together. I'm both attacking the device that's connected to a network, and I'm also creating the access point. So as soon as that device connects to the access point automatically, it's going to get served a phishing page. And if that person is unfortunate enough to put their password in that phishing page, you can see they just hit the phishing page. Now they're probably typing something, and boom, we get the password. So we just got the password, my password, which is not my password, so don't try it in any of my accounts. But my password 123, that's my secure password. You can see that it's just as simple as that to force somebody onto an insecure network that basically steals any information they put into a phishing page that's popped up. And on the left, you'll see the actual phishing page that I was typing into. This is on my cell phone. And of course, it thinks it's at Burger King. It's like, hey, you're Burger King, give me your password. But in general, you'll see this in attacks like the Armageddon attack, which kicks somebody off of their device, kicks someone's device off of their network, offers up a plausible page that looks like their router's update page on an open Wi-Fi network with the same name, and entices people to put in the password to complete the update, and basically won't give them Wi-Fi until they actually do it. Now, this is not all bad. We've also put this together into a hacker game so that people looking to do things like crack passwords can do so without getting in trouble. If you have a single ESP8266, you can actually play back traffic from multiple devices, which means we can capture a handshake and then just play it back from an ESP8266 on a loop. So if you have a Raspberry Pi or a wireless network adapter that's capable of capturing handshakes, then you can capture them and crack them without needing to deauth anything. Because for a lot of schools and other organizations, deauthentication attacks are a deal breaker because the students might accidentally deauth the wrong thing. Now, we put together something like this for the RSA conference, and you can see here, we actually took two microcontrollers and connected them on the back via serial, and we had one of them create an access point and the other one join it continuously. And we like this solution because we were able to just send it a command and it would reset itself to a different password each time. And rather than having to capture traffic, store it, and then upload it to the ESP8266 on a single device, which is possible, but a little tedious to change, we were able to make a Wi-Fi hacking game that was able to be changed in seconds just by linking these two devices together. We also created the absolute best game I've ever created, the Chicken Man game. And you can tell it's good because of the ASCII art. Now, what this is basically two different teams. Each team gets a Raspberry Pi computer running Kali Linux, and then we have two access points for them to hack, each on an ESP8266. Now we have a third ESP8266 that keeps the score and also lights up a string of NeoPixel LEDs. And as one team starts to win, it'll shift the lights from one team's color to another, so any spectators can see who's winning. Now, this is a really cool game because it lets large groups of people get together and hack. It's a safe target that people can basically attack that will react to their attack so they can see when they're winning. And it's a really great way for groups of people to learn to do this. So if you want to check out a really great Wi-Fi hacking game, Stefan, myself, and my friend Brandon all collaborated on this project, and it's proved to be very popular. Now, our future goals for this project are numerous, and we're almost out of time. But basically, we're looking at customizing phishing pages, making proximity-based sensors, so basically being able to tell when a device comes close by monitoring signal strength, and either triggering a script like maybe doing some deauthing on the device, or plugging this into a computer so you can monitor the signal strength of a targeted device and maybe execute a script on your laptop as soon as a certain device is nearby. You can also expect us eventually to get around to doing more signals intelligence stuff because that's a big passion for Stefan and I. And I'm really passionate about trying to eventually exploit Internet of Things devices automatically after we're able to detect them by their vendor ID. Now you can, if you have any ideas for Wi-Fi hacking games, please send them our way because we really want to develop more interesting Wi-Fi hacking games that make this sort of thing safe, fun, and effective for people who want to get out there and do this. And of course, the ability to record full PCAP files to actually grab handshakes and maybe even try to crack them against a really common list is something we're looking at in the near future, just to get the absolute lowest hanging fruit and see if we can actually do some cracking on the ESP32. Now, if you want to follow up with anything you've seen in this presentation, check out our Discord server. You can see the link on the top there. You can join our meetups, which are no longer just in LA since everything is online here at the Cyber Weapons Lab LA meetup group. You can also check out the Chicken Man game, the ESP8266 deauthor, the Hunator serial monitor, the deauth detector, WPA2 handshake generator, the 2 ESP8266 Wi-Fi dual game, the beacon spammer, and finally the ESP8266 CTF game compilation GitHub at these links here. Please go ahead and take a picture or check this out later. I think you'll find all of these links very interesting. So that's our presentation. Thank you, Stefan, so much for not only joining us today, but also doing all of this incredible work on making these small, low-cost devices accessible for anybody who wants to get started with Wi-Fi hacking, as well as advanced hackers who want to maybe start scripting attacks that wouldn't be possible for such a cheap price if you hadn't put in so much work.
Yeah, you're welcome. I mean, this is quite fun for me too. So, yeah.
Cool. So that's our time. I'm looking forward to any questions in the Q&A. And again, if you want to follow our work, you can always follow me on Twitter at Cody Kinsey. And Stefan, what's the best way to follow you?
I guess Twitter works at Spacehoon, or just anywhere else you find Spacehoon.
Anywhere Spacehoons are sold, you can find Stefan's work.
Yeah. Also,
All right, guys.
To iterate more, we are working actually on a new Discord community. You saw the link in the previous slide. So if you want to join, you're welcome. Yeah.
Yeah, please. We would love to talk to you, hear your questions, and even if you don't get a
Ideas.
chance to ask your question or give your idea in the Q&A, you can always do so in our Discord community. All right. Thanks, guys. Bye.
Bye.
Okay, so thanks for staying with us, and welcome back. We've got Stefan and Cody with us, and Cody has an announcement about a workshop coming up. Go ahead, Cody.
Awesome. Well, first of all, this was my first conference talk, so thank you guys so much for watching it. If you are interested in the subject, we actually have a workshop coming up tomorrow where we're teaching you guys to use the version 3 of the deauthor. So if you're interested in that, please check it out. It's on the Hope conference website, and you'll get to actually learn all the stuff that we're talking about today, as well as try it out for yourself.
Very good. And I think we do have a couple of questions in the chat. But while I'm looking for that, I do have a question for you about when you're using your tool, are using the, what kind of batteries do you usually select when you're running your device? Does it come with like AA's, or, do you need more power? How does that work?
Stefan?
Yeah, so if you just run it on like a bare development board you can buy, then you just power it over USB. There are boards that have sometimes a LiPo battery connector, some like JST, whatever standard it is, connector. So those would be 3.7 volt LiPo cells you can buy on, for example, Adafruit. Yeah.
Right. Okay. And one of the questions that I want to know is, do you have a story about how you might have used this for a business where they were under attack and your tool was able to resolve the issue?
Well, Stefan, you want to take that, or shall I?
I think you probably have better stories than I.
Well, all right. So this tool is both offensive and defensive. And we've shown some examples today of how you could use this to do an attack, or how you can also use it to detect attacks. So for us, I found it really easy to just solder this together on a perf board and use it as kind of a permanent way of determining whether an internet issue is being caused by a potential attack, a misconfigured router, or something like that that might be setting off the authentication to packets when it shouldn't be. One example was there was a while where I was living in Los Angeles where there was a neighboring network that was configured to like disallow devices that were trying to connect to it. And for whatever reason, it was just deauthing devices that it shouldn't have been deauthing. And we were noticing a bunch of problems problems with our internet, and we could not figure out what it was. But as soon as I wired up the DAuth detector, I was able to very quickly determine, like, hey, there's a bunch of DAuth packets going around, and I was able to see how frequently it was going. So if you wanted to just hook this up to an LED and use it to detect when your network's under attack, it's a really easy way of ruling out script kiddie attacks or things that are really just simple for anyone, well, in this case, who has about $1 and a microcontroller to do.
That's very interesting because, I can't, being in the business, clients call up and say, my Wi-Fi, etc. I'm sure you know the drill. Let me just check the chat and see if we have anything here. Is there anything else that, I don't see any more questions, but is there anything else that you wanted to add to your video before we finish up, or
Couple
Stefan?
things. One question that we also get all the time is, does this work against 5 gigahertz networks? And the answer is no. As of right now, this little microcontroller, I have one because we have hundreds everywhere, but this little microcontroller only works on 2.4 gigahertz Wi-Fi. So if you have, for example, a device that has both 2.4 and gigahertz Wi-Fi, and you kick it off of its 2.4 gigahertz Wi-Fi, thinking you're going to capture it on an evil access point, and it just moves over to the 5 gigahertz network, you're kind of screwed. There are some limitations to this, but we're really enthusiastic about how much you can do and how far we've come with these attacks. And there also are microcontrollers out there that do have 5 gigahertz access. We're looking at some that are, I think, from Texas Instruments that are really promising. So there are some really exciting advances that are coming out that we're looking at that might make this more capable in the near future. So if you're interested in this stuff, I highly recommend that you try it out for yourself. They are super cheap. And if you want to support our project also, you can pick up kits for these on the hackerinterchange.com website. And you'll find the link also in our workshop for tomorrow.
Yeah, I want to add that as far as I know, Espressive is working on a 5 gigahertz ESP32, but who knows when that's finally released, and even when it's released ready for us to be used. So that could take a while, but I'm sure 5 gigahertz chips are just coming. Just have to wait.
Yep.
That makes sense. All right. I think we're out of questions. I want to thank you all very much. It was very, very, very impressive. And you put a lot of time into all this work. And thank you for sharing it with Hope 2020.
It was our pleasure.
All right, and we'll see you around
so
the show.
Cool. See you guys. Thank you.
Yeah, thanks.
Thank you.
Bye.
All right. Yeah. Bye-bye.